All right. Hi, everyone. Thanks for coming to the Data Matters seminar, both in person and to those of you online. I want to welcome our speaker, Associate Professor of Anthropology and Archaeology in the Ancient World, Parker Van Valkenburg, who's going to talk about South American archaeology at scale and using vision foundation models. So that'll be exciting. Welcome.
Thank you so much. So I have been very fortunate to be warmly embraced by the DSI as a member of the community, and I at the same time realized that I don't know a lot of people in the community. So if there are folks here I haven't had a chance to meet, people online who haven't had the chance to talk to, I hope I get an opportunity to do so at some point. I'd like to talk today about work that I've been doing as part of the leadership team of this project called GeoPACHA, the Geospatial Platform for Andean Culture, History, and Archaeology. And in addition to the folks on the title slide, there's a much wider range of collaborators who've been part of this project over its second stage recently. So our core team is me here at Vanderbilt, or sorry, me here at Brown and a core group of people at Vanderbilt, including Steve Wernke, very close colleague at the Department of Anthropology there, who will be here next week. Encourage everybody to come to his talk, which has nothing to do with GeoPACHA. A couple of computer scientists, Yuan Kai Huo and Junlin Guo, who are also at Vanderbilt, and James Zimmer-Dauphiny, who is the glue that bridges the data science and computer science parts of the project to the archaeology side. In addition to this, and this will become clear as I talk about the structure of the project, we've got an amazing set of collaborators who are archaeologists who work in distinct parts of the Andes and know a lot of things about the very particular types of data that archaeologists collect in different valleys and so on and so forth. And that is one of the fundamental problems of dealing with archaeological data, is that they're very particular, they're not modular, and in order to transform artifacts into numbers, you need people to tell you the best way to do that. So I'd like to do hopefully 6 things in the course of this talk. Discuss the general problems of scale in archaeology that we've been trying to solve. Present the first solution that we developed for dealing with those problems, GeoPACHA 1.0. Present a case study based on that work. Move on to talking about the ways in which we're now trying to leverage vision foundation models to expand our coverage. Present a preliminary case study from that work, and then discuss in at least a few lines the larger questions about AI and archaeology. So archaeologists are very good at telling small stories. A typical picture or image of an archaeologist is of someone hunkered over in the ground collecting tiny things and telling you a lot of stuff about those tiny things. Now, archaeologists don't just dig. We also work in labs, and we conduct, when we want to know things about the way that sites are distributed within a landscape, something called archaeological survey. But even archaeological survey is relatively geographically intensive. The most well-known and extensive archaeological survey from Latin America is probably the Valley of Oaxaca survey, conducted over the course of a decade. And the researchers painstakingly walked across the landscape, recorded individual sites, collected ceramics from the top of them, and guessed at how old they were. And yet that effort covered only 2,900 square kilometers, which constitutes a very small portion of the overall picture of Mesoamerica. Now, this is a problem for a number of reasons. And one of those reasons is that ancient people didn't just think in small boxes. They didn't just think about the ground in front of them. They were part of these larger geographies, including empires and trade networks, and imaginary horizons that extended far beyond their individual villages. And we don't capture archaeological data at those scales. We still talk about those scales, but we do so using kind of geographic shorthand, creating blobs on maps. The 3 flavors of blob you may have been introduced if you went to school in the United States. The 3 blobs that you would have seen scattered in Latin America are corresponding to the Inca, Maya, and Aztec cultural areas. But the actual geographies of these incredibly complex political machines look nothing like that. A better approximation might be the Inca road system, but that's still an abstraction. And if we want to understand at a high level of detail, a geographically expansive polity like this, ground survey like that done by the Valley of Oaxaca survey is just not, it's not powerful enough. It's not extensive enough. Another problem is that beyond simply the imaginary horizons of these ancient polities, archaeologists conduct work that would benefit from understanding a wider scope of variation within the landscape. So if we want to understand why empires develop, if we want to understand the impacts of demographic growth on landscape, if we want to understand whether or not the Spanish invasion of the Americas is somehow causally linked to the Little Ice Age due to the reforestation of the Amazon, we need data collected at much larger scales. So somebody has entered something in the chat. Okay. We can sum up these practical challenges as being the following. Pedestrian surveys and excavations, which are really good for some things, are not very good for extensive coverage. In addition to being time consuming, they are also expensive. Archaeologists make generalizations anyway, but we do so based on really unevenly distributed samples. We go out and we work in individual valleys that we may work in because they're accessible or because we have a cousin who lives there or because they happen to be located in a national funding landscape where we can work more easily. And then we generalize. We take what we see at the valley level and we talk about the Inca Empire broadly writ. Another challenge is that because archaeologists work in these localized places with highly idiosyncratic data, we create our own vocabularies to describe those data. And linking those data across different geographies is also extraordinarily complex. So data integration itself is not necessarily the best solution for this. And so we are stuck in a situation right now where we oftentimes are missing the forest. We oftentimes lack a framework for even understanding the variability of the things that we study, and we guess at the totalities that our samples describe. So like I said, the sort of first wave of attempts to deal with the problems of large-scale data collection and integration in archaeology have focused on linked open data repositories like the Digital Archaeological Record, TDAR, Open Context, and English Heritage. And data, some kinds of data work well like this. These are good formats for things that are already modular, like coins, with repeatable size, certain features that can be recorded in a standard way. English Heritage is particularly good at this because there's a lot of kind of avocational people searching for Roman coins in English fields. But then there are all kinds of other data that don't work particularly well for this, including the distribution of sites themselves. Another solution for collecting geographically extensive data is what we would call virtual prospecting, which involves looking for sites in some kind of imagery, training people to do so, and covering as much area as you can, which, as you will see, is one of the solutions we took in the first stage of this project. It's a powerful way and a useful way to collect certain kinds of data, but it also runs into problems of extension. It's just really difficult for a small number of people to map millions of archaeological sites. So about 5 to 10 years ago, what archaeologists who are involved in data science started to do is to think about whether or not crowdsourcing might be this useful way to identify sites en masse. You could train citizen scientists to go out, they would map archaeological sites, and we would come up with these incredibly rich data sets. And citizen science has been really powerful for certain kinds of things, like recording certain kinds of data that are maybe a little bit more like those Roman coins than they are like complex ceramic pots. So the recognition of the ability to recognize birds by their call, for example, and so on and so forth. Unfortunately, when applied in archaeology, crowdsourcing methods ran into a number of issues. One of the most widely publicized attempts to crowdsource archaeological data collection was Albert Lynn's search for Genghis Khan's tomb, which was extraordinarily successful at roping in or calling in members of the public to participate in archaeological research. There were 10,000 volunteers. They worked for 30,000 hours and they identified more than 2.3 million potential features. However, when checked against actual archaeological data, it's estimated that only around 53 of the features that they identified were actually archaeological sites. People who are untrained are really bad at recognizing archaeological features in high resolution satellite imagery. Now, yeah, thank you, thank you. So a feature is a word that I am using to avoid saying site. Um, an archaeological site is a somewhat slippery concept because its boundaries aren't easy to measure empirically. Like if we think as archaeologists coming into Providence, how would we know what Providence is and what Pawtucket is? Now they're administratively different, but we can't separate them. So basically what we mean here is a discrete, normally object-like, like in computer vision terms, object-like entity that can be delimited with a box. Awesome. With some caveats. So another attempt to leverage the same approach that actually used some of the same code base that Albert Lin used was Sarah Parkett's GeoExplorer project, which was funded by a TED Prize 10 years ago and began with the ambitious objective to map all of the world's archaeological sites in 10 years. Um, Unfortunately, in part because there were no local connections or no substantial local connections for the project, but also because we think the data that they produced was almost unusable, this project has not resulted in any publications. Any. It was a good public relations project, but scientifically does not seem to have borne fruit. Um, in general, virtual survey, of which GeoPACHA 1.0 is one example, faces both practical and ethical challenges. One of those issues is that a lot of archaeological sites are not visible in satellite imagery. Cave sites will not show up in satellite imagery, for example. The second is this issue we've already discussed, which is difficult to scale feature detection using crowdsourcing methods. As we saw in the case of GeoExplorer or Global Explorer, there's sometimes a temptation to catalog sites instead of focusing on research questions. If you set out to map all the sites in a location without thinking about why, you end up with problems when you get into the end of the research pipeline. And then there's also a very serious potential for voyeurism if projects aren't built collaboratively and don't attempt to complement existing fieldwork. So if you're not asking permission to work in the places where you are deploying large-scale site detection, you can run into problems. And this became an issue this last summer when OpenAI ran a contest to get people to try to develop models to identify archaeological sites in the Amazon basin. And then there was an official complaint from the Brazilian Ministry of Culture that no one had consulted with anyone in Brazil about this. And OpenAI, as is their wont, plowed ahead, and they have people who have no archaeological experience and no connections to Brazil identifying sites en masse in the Brazilian Amazon, and presumably they're going to publicly make this information publicly accessible and put those sites at risk and violate indigenous territorial sovereignty. So there's some really serious issues here. And I will humbly attempt to discuss the way we've tried to deal with those. So beginning in 2019, in really serendipitous timing for the pandemic, which kept us from being able to do archaeological fieldwork for a while, Steve and I, at this point, we weren't working with UNCI yet, started this project based on what we would call a brute force model. Not brute forced in the machine learning sense, the way that that Rich Sutton talks about it, but brute force as small groups of archaeologists just creating dots on a map, points on a map based on our ability to identify sites. We built this web app that contains a sort of common vocabulary or database for describing archaeological features that we came to an agreement with our collaborators about. But we encouraged these different teams of researchers working in different parts of the Andes to pursue their own research questions. So if you're interested in pastoralism and the history of land use around llamas and alpacas, you might want to tag corrals. If you're interested in the evolution of defense networks, you might map hill forts. Another example, we were mapping agricultural terraces to try to understand why terraces were located in particular places. But effectively, we just had teams of people who were working in this web app and painstakingly going through publicly available satellite imagery through like the Google and Bing APIs, and tagging those individual features. And the result was the following data set that covered around 180,000 square kilometers, which was a larger area than anybody had ever covered before, and yet still only 10% of the historic footprint of Tawantinsuyu, the Inca Empire. To give you a better sense of that scale, here's one of those Valley of Oaxaca surveys located in one of our survey areas. Sorry, folks in the room. It looks like this cable is a little bit finicky, but it's coming back. So I'll need to share again, and I'm not going to walk anywhere near that cable because it is enchanted. And now you can read my notes. There we go. So yeah, I won't go into too much detail about the app design and the way we collected the data because that's relatively uninteresting for this audience, I think. But um, one thing I wanted to clarify really quickly is that the imagery is not anything special. We've had many colleagues contact us and ask us if they could have access to it, and we just point them um, to Google and Bing and Mapbox and Esri and so on and so forth. That said, one really exciting part of the project has been that we do have some access to historic aerial photography. Beginning in the 1930s, there were a series of aerial photographic expeditions that were flown in Peru, some by adventurers like this example, but then also by the Peruvian Air Force, which was attempting to map all of the country's territory using aerial photography to catch tax cheats. It thought that these hacendados, these large landowners, were not accurately reporting how much land they had, and it's true. So they conveniently took advantage of the fact the United States government was interested in mapping territory in Latin America during this period of U.S. empire, and in order to sort of counter Germany's interest in the same area, and mapped a ton of the coast and the highlands. And we've got something like several hundred terabytes of scans of these images that we haven't yet been able to work with. The ones we have been able to work with, we've been able to create these three-dimensional models of landscapes in the 1930s with a 25 centimeter resolution, which is amazing time travel. You can zoom in and see a lot of archaeological sites that have since been destructed. So the result of this first scale of the project was we had a number of kind of case study papers that came out just around 2 years ago in the journal Antiquity, which folks can access using this QR code, or I'm happy to send it on to you. Now, I wanted to give you a sense from this first stage of the project, what good is this actually for? I came into this having been and continuing to be a field archaeologist who studies things using a trowel and a screen. And one of the things that I've worked on is trying to understand how indigenous people were impacted by forced resettlement in late 16th century Peru, a time at which this guy, Francisco de Toledo, attempted to move more than 2 million indigenous people into the planned towns that were called reducciones. Steve will be talking about this phenomenon more next week. The historic record of this process has been relatively well studied, but it's scarce. And so I entered into this work doing ground archaeology in order to understand small stories and to be able to speak back to these big colonial generalizations that show up in administrative documents about this process, to document indigenous health, diet, the configuration of indigenous houses. How do they actually compare to the norms that show up in colonial documentation? Both Steve and I did that working in distinct parts of the Andes and found really different patterns. And so in order to get a better sense of the overall distribution of these towns, the geographic factors that influence their location. We went into historic documents, and actually some of this work was started by Jeremy Mumford, our colleague in the Department of History as well. We went into these documents, found the names of all the towns into which people were forcibly resettled in the late 16th century, found as many of them as we could using modern town names. And then we went out and we actually conducted a visual survey looking for the characteristic gridded plan of the Reducción town in areas where there weren't modern settlements. So we found a number of these abandoned reducciones all over the country. We then plotted those locations on a map and asked some really simple questions about their distribution. First of all, do they cluster in a particular part of the country? And also, what geographic factors do they correlate with? One of the first things that became evident is that they're not evenly distributed. I think there's this sort of commonly held mental picture that all of these towns are found in every single valley and they're found in equal density. And instead, what we found when we actually plotted them is that there are high concentrations around, I'm going to try to avoid touching that cable, around the Inca capital of Cusco, and to the west, and then around the colonial capital of Lima. And we think that what's going on here is actually that the resettlement of indigenous populations during the Spanish period is happening at a relatively localized level. People are being moved a matter of kilometers. This concentration, we think, is a legacy of Inca imperialism, because we know historically the Inca were moving tens of thousands, hundreds of thousands potentially of people from throughout their empire in around their capital. And the Spanish came in and resettled those people more or less where they lay. Another thing that was interesting to take a look at is their distribution across altitude. And what we see here is that there are much higher numbers of these towns found first along the coast. As you can see here, the x-axis is elevation, and then between 2,000 and 4,000 meters above sea level, which makes a ton of sense because that is the ideal band of elevations for Andean agropastoralism. You get maize agriculture down in the valleys, and then you get camelid pastoralism just above that. The camelid poop is used for fertilizer. Camelids in turn eat leftover things like stalks from maize. Camelids provide wool. Potatoes can also be used. Well, camelids don't need to eat potatoes, but there's this sort of synergy between these things. And so this makes a ton of sense. But in some ways, the most interesting result that we got from this first stage of analysis was comparing the location of these colonial towns to pathways of Inca roads. We took a look at the Inca road system earlier. It's one of the most incredible systems of transportation in the ancient world, stretching over 6,000 kilometers up and down the Andes. And we had access to a data set of all of the recorded sections of the Inca road provided by our colleague Giancarlo Marcone, who was then in charge of this big UNESCO project looking at the conservation of Inca roads across 6 different countries. So the basic question was, are the reducciones, these planned towns, found in closer association with the roads than randomly distributed points? And they definitely are. The median distance between the reducciones and the road sections is around 9 kilometers, and 5 different collections of random points, randomly generated points, have median distances between 16 and 18 kilometers away. And the statistical comparison leaves no doubt that there's this meaningful association between them. So what's actually going on here? In some ways, we think it's a rather similar process that led to the one that led to the concentration of populations around Cusco. But in this case, the Spanish are actually probably using the Inca road system as their own circulatory system. The Spanish coming in wreak havoc on indigenous societies, and it is difficult to underestimate the amount of violence that those societies suffered. But the model of colonialism we think we should be using to understand those impacts is not one of complete and utter erasure with a focus on land, but rather a colonization that operated somewhat more like the infection of a host by a foreign pathogen. the existing circulatory system of the Inca Empire was colonized by the Spanish, who used it in order to sort of insinuate themselves. Now, the issue that we started to face as we took a look at our data quality here is that there's a lot of area that we weren't able to cover and a lot of features that we weren't able to record. And then we also started to notice some interesting patterns in terms of how well the human users were actually labeling the individual archaeological sites. James Zimmer Dauphiny, our colleague, the postdoc at Vanderbilt, took a look at a comparison between the results of a convolutional neural network analysis of archaeological site locations within a 12,000 kilometer area with the same results that were produced by our GeoPACHA teams in those areas. And for anyone who's done comparison of CNNs and human users and their ability to recognize patterns, this will probably not be surprising. There were some things that the humans were really good at. And there were some things like attention span that the humans were not particularly good at. This confusion matrix here shows us the CNN on the left and the human expert on the right. And here, the number of false positives that humans identified is really low. So our archaeologists looking at these images do a really good job of actually, when they say something's an archaeological site, it's an archaeological site. They're not like the people who participated in that Genghis Khan survey. However, there are many places where there are archaeological sites that they did not see them. And we think that's in large part because if you stare at a screen for 2, 3, 4, 5, 6 hours, it's really difficult to stay focused. And so it became clear that the next step for the project for expanding was to develop a human in the loop, human machine teaming approach in which we would attempt to automate the process of identifying sites and then integrate some amount of manual verification and augmentation and then improvement of the model. And we would tweak it so that we would tweak the model so that it would identify more sites rather than fewer, because false positives are way easier to deal with than false negatives. Now, in the process of doing this, we started to work with Yuan Kai Huo, who is a colleague whose primary research involves medical applications of computer vision, so like developing models for detecting tumors in MRIs and things like that. And he immediately provided expertise that our team lacked. And that's how we have come to do this work on foundation models. Starting with 2 grants, one of which we got around 18 months ago, and another of which was an NEH grant that was canceled by Doge. Thanks, Doge. We have attempted to expand our coverage out to 2 million square kilometers and to use the data that we collected during the first stage of GeoPACHA, the human labeled site locations, to train those models. A really key part of this has been that we have continued to work with teams of regional experts to help us identify and vet the archaeological site identifications. So for the non-archaeologists in the room, the data science people, I apologize because I am not a computer scientist. I don't specialize in computer vision. And so this is a kind of dummies interpretation of the way that all of these things work. But for those of you who are not familiar with the distinction between foundation models and traditional AI, here's a quick slide to say something about that. Traditional AI, so here we're thinking of rules-based, classic machine learning, neural networks, like what the most archaeologists are actually using right now. 95% of what you'll see if you go to an archaeology conference and see people using AI, it's all people using neural networks. Tend to be trained for specific tasks on more limited data sets. And they oftentimes use off-the-rack models trained on things like the distinction between dogs and cats. Foundation models are much more expansive and flexible. And so they are trained on a massive corpus of pre-training data. They're adaptable for flexible downstream tasks, ranging from object detection to segmentation and classification. And they, in comparison to traditional AI, are much more accurate. A couple of examples include SAM, Segment Anything, and Dino V2. And the first foundation model that we built is based on Dino V2. The one that we are currently developing with colleagues at Oak Ridge is based on Dino V3. In remote sensing, there have been a number of different foundation models that have been developed, which include SkySense and DynoMC, et cetera, et cetera. So the way that we went about doing this is that we first accumulated a bunch of satellite data, which we got through a gratis agreement between NSF and Maxar. Millions and millions of dollars worth of satellite imagery that we could freely access, I think because Maxar, which now has a different name, relied on NASA infrastructure in order to put their satellites into orbit. And therefore, and many of you may have had access to this already, one can gain access to a lot of satellite imagery, not newly tasked satellite scenes, but archived satellite images for research purposes. In order to get those data into shape for actually training our models, what we had to do was search for the imagery, find images that have relatively low cloud cover, so mostly in the dry season when you can see archaeological sites against the vegetation backdrop, orthorectify those images, mask out the clouds, eliminate overlap, pan sharpen them, and create cogs. This is a sort of workflow of the very non-trivial stuff that James did over the course of a year to get our data into shape in order to train the model. So the first version of the model is based on a collection of satellite images stretching from northern Chile to southwestern Ecuador. That is based on a highly modified version of Dino V2 that's specifically tuned for 8-band imagery, because the images that you see here aren't just RGB, they include these other like near-infrared bands and so on and so forth. It's mostly Worldview 2 and Worldview 3 imagery. And in this first version, we used 3,256 by 256 pixel chips. For folks who are interested in this, because this is a concern that people seem to always ask about in archaeology, I wanted to provide a little bit about the resources that we use. So it's 2.56 terabytes of GPU memory over around 157 hours, producing 0.2 tons of CO2 equivalent, which is around 1/15 of how much carbon I was responsible for emitting into the atmosphere on my last international conference trip to Athens. So it's not non-trivial, but I think it's really interesting the way that we bracket some of these impacts and think about AI somehow differently than the kinds of things that we have done as part of our academic lives for a very long period of time. And rather than excusing ethical thinking around AI, what I'd like to do is extend that ethical framework to think about the other kinds of things that we do. With this model, we have been using it for several downstream tasks, including object detection and also semantic segmentation. The object detection work has mostly focused on identifying, this is getting back to the features question, corrals, unroofed buildings, and roofed buildings. So discrete things that you should be able to put a box around in an image. When we were running it with the 256 by 256 chips, those things had to be relatively small. In our new training for some Deep Andes 2.0, our second foundation model, we're using a much larger area so we can see larger things. But there's some things that we're interested in as archaeologists that can't be easily and discretely defined. So terraces. If you've ever taken a look at a terrace landscape in a satellite image, it's really difficult to actually draw a box around an individual terrace or group of terraces. They don't really behave like objects. So how do you identify them? It's much easier to use a segmentation model. If you're not familiar with segmentation models, uh, what they involve doing, or a segmentation task involves, um, when applied to a raster image, it involves going through and classifying each individual pixel based on whether or not those pixels correspond to a given class. So for us, those classes are terrace, in use, abandoned terrace, and no terrace at all. And this is a useful thing to do because there's massive areas of abandoned terraces in the Andes that were built in antiquity by indigenous people, and we're not totally sure why they were built where they were and why they were abandoned. Were they abandoned because of the Spanish colonization and the devastating effects of Spanish colonization on indigenous populations? Were they abandoned because of the Little Ice Age, because there was greater frost risk at higher elevations? Were they abandoned because of modern urbanization, as people have been practicing less farming and migrating to places like Lima? Are we seeing a contraction of agricultural activity? So by looking at this stuff at scale and comparing the location of the abandoned terraces to active terraces, to elevations, to climatic factors, we can sort of get at that. Um, so this is just to give you a quick look at the auditing process. We built another web app for having our teams audit the results. They go through and they look at the individual feature identifications that were output by the model. They uh, evaluate them and say whether or not they've been correctly identified. There's a certainty bar or a slider. And then we take these results and we feed them back into the training process to improve the model. This auditing process, which we did last year, the first stage of it uh, included the review of 133,000 individual features and secondary reviews of 64,000 individual features. So what we decided we would do is we would have two different archaeologists look at the same feature and decide whether or not it was actually a corral, say, or an in-use corral or an abandoned corral or one of the other categories. If they agreed, then that was added to the canonical database. If they disagreed, it was passed up to editors, us, who would then review it. And if we decided that it wasn't a feature, it was removed. And if it was, then it would be added to the canonical database. This process identified a total of 13,788 false negatives and is now being ingested back into our training process. So our next steps here are to refine the model with the audit data, which we haven't done yet, to deploy the model over the entire Andes, to go back in and enrich the feature identifications with attribute data, and then open them to registered archaeological users. So with the proviso that we're still working on this, and we still thankfully have a couple of years left on the grant, wanted to show you one application of the second stage of the project, and specifically to bring up this issue of terraces. As I mentioned, I think everybody who works in the Andes know that there are a lot of terraces and a lot of abandoned ones. But if you look at the literature, there are major disagreements about how extensive an area is covered by these features and how many of them are actually abandoned. Masson in 1986 estimated that there were over 1 million hectares, 75% of which were abandoned. Wright estimated 80% of abandonment in just northern Chile. William Denevan, the eminent geographer, estimated 42% abandoned, of which, and actually 61% of a particular type of terrace, the bench terrace, were abandoned in this one valley. And then if you go to this NGO, ONAM, they estimated that only 16% of all terraces had been abandoned. One of the reasons that we see such disparate estimations is that we really just don't have very good data. So James, as part of his dissertation, in an earlier stage of our model development, took a look at 81,149 square kilometers of survey area in the Southern Andes and examined individual, it basically developed a model for detecting terraced and abandoned terraced landscapes. The model was built on the back of training data painstakingly put together by our Peruvian colleagues and students. And they went in and drew these very detailed polygons around areas of in-use fields and abandoned fields. So in-use green, abandoned red. And when the model was deployed over this massive area, we see really, really uneven coverage. My mind's eye, honestly, is that this entire area would have been covered by terraces. But we see a lot of concentration around Lake Titicaca, which is really kind of it's difficult to overestimate how important it was as a productive center in antiquity and even today in the Andes. We see large swaths of terraces also found in these valleys that flow down from the Andes, and there's much more uneven coverage in between them in these higher locations. If we look at these maps at slightly higher resolution, you can start to pick up here. This is right around the Copacabana Peninsula and Lake Titicaca. We have still in use fields and terraces down around the lake, and as you move up further away, you start to see higher numbers of abandoned terraces. If we take a look here to the southwest, we see a pattern that's a bit more complicated with what looks to be preferential abandonment on one particular aspect, one particular edge of the landscape. And one final example here from Cabana Conde in the lower Coco Valley shows us that there appears to be a close association between in-use terraces in this town located in the middle, suggesting maybe that there was preferential abandonment of terraces that were located farther away. But the numbers that James produced are the following. In terms of actual terraced area, he found that a somewhat lower estimate than many extant estimates was more accurate. 23.6% of all terracing in his survey area was abandoned. And if we look at that in terms of the total survey area, only 5% of it, 4.8, actually less than 5% of it was actually covered by active terraces. Only around 1.5% of it was covered by abandoned terraces, and only 6.3% was ever terraced at any one point in the past. So what we see here is much more uneven than what our mind's eye might show us. Patterns of abandonment within this landscape paint an interesting picture. And I offer this data from a paper by James and Steve, just to show you the potential not to claim that we've really cased this problem yet. We've got a lot more work to be done, and we've only been focusing on one small part of the Andes. But this initial analysis suggests that both elevation and slope were really important factors in predicting terrace abandonment. On the left here, you see that in these two different regions, the median elevation of abandoned terraces is significantly higher than active terraces, although of course there's plenty of exceptions there. And then if we look at the slope and we compare the abandoned terraces to the active terraces, the median value for the abandoned ones is considerably higher than the median value for the active ones. So this sort of makes sense, potentially in the context of demographic decline, which we need to study at a finer level. We're seeing people preferentially abandon terraces that are farther away, that are harder to get to, that are harder to farm. And I hope that we have a more complex picture as we expand out, because my suspicion is that we're going to see different factors driving abandonment in different regions for all sorts of complicated reasons. So just to wrap things up here real quick, I think that even beginning with the first stage of this project, the data that GeoPACHA has helped us generate is assisting in mapping phenomena on a much larger scale than was previously possible. But it's important to understand that the work we're doing is really different. There are many types of archaeological features, human experiences, and research questions for which this method is completely useless. And it is not in any way intended to be a replacement for existing archaeology. it creates what might be better understood as deflated or aggregate signatures of human occupation of the landscape rather than a detailed chronology of how people occupied it. Think of my favorite metaphor is the way that sites look in very sandy landscapes. Has any archaeologist here ever dug in a very sandy place? Lorenzo has. When you don't have a solid matrix holding levels apart from each other, and you've got a lot of wind, the stratigraphic differences that separate artifacts start to break down, and everything sinks down to the bottom. But of course, you all know what this looks like because you know what the streets look like here when the snow melts. It's full of detritus and cigarettes and all sorts of things we'd rather forget about. And that is, I apologize for the slightly gross metaphor, what we're seeing here. We're seeing an aggregate of many millennia of human occupation visible on the surface, and it is that this kind of method can pick up. But in doing so, I think it provides us with a really important frame of reference for the much more small-scale questions that archaeologists tend to look at. Indeed, I think it is probably actually that scalar point of reference that this technique is most useful for. And going forward, iterative checking between fine-grained archaeological data and large-scale satellite imagery is going to be really, really essential. Thank you so much. I look forward to talking.
From the audience, or I can get us started with a question. Nobody has something they want to immediate question. So one question that I have is sort of a little bit more about like data in your field. And so one is like, to what degree do you think that data science skills and like data fluency is going to become an essential skill for students who are entering your field?
Good question. Archaeological data is, in comparison to data in a lot of other fields, really expensive and time consuming to collect. I mean, of course, it's very, very expensive in other fields too. It's just that there's not a lot of profit motive for collecting archaeological data. So we don't get the kinds of grants that enable us to aggregate things the way that is happening in OpenAI and Anthropic and places like that, of course. The other thing that is particular about archaeological data that I alluded to but did not talk as much about in this presentation is that they're very particular. So data science, I think, will be and is generally relevant across archaeological practice, but it is difficult to gain access to data sets and work on data science problems constantly in archaeology because the data themselves are so bespoke and hard to access. And I think in some ways, although if you are someone who wants to study large scale processes, that can be frustrating. It's actually an important handbrake because it keeps people from being able to do the kinds of, there's a process of permission that needs to be requested. And once we start removing those barriers, questions about data sovereignty and access become thornier. And yeah, I think all that said, it is my hope that we're moving to a point in archaeology too, where we no longer feel the need to go out and dig new sites. So much data already exists, or so many things can be turned into data and then processed and studied in new ways, that there are wonderful opportunities to just be a data science archaeologist. I'm hoping that some of the students in the room and future students as well will take that up, even as they don't leave behind the kind of localized, grounded commitments they have to the places they come from.
The audience.
Thank you so much. I'm interested in some of the, I appreciate how much you talked about the ethical dimensions of this work, and especially you mentioned this project in Brazil, right, where it was not appropriately consultative. And you mentioned having like credited credentialed archaeologists basically giving access to your data or making it open source only for specific people. Can you just say a little bit more about the guardrails and like what are you thinking about? What are your worries about? Who would you be worried about getting access to this?
Mhm.
How do you try to manage that and manage your partnerships, your collaborations with communities?
Yeah, great question. I think that the answer to that has changed over the course of the project. When we first started, I think I was most worried about the locations of sites that are hitherto unknown to the public being released and those sites being threatened. Sometimes not by people who were going there to pot hunt or treasure hunt, but maybe by mining companies that wanted to destroy evidence that those sites existed before they expanded. Those of you who don't know, in Peru, like in the United States, but in Peru, that's more complicated and thorough process in some ways, even if it's not always doesn't meet its legal standards. Um, Mining companies need to go out and conduct mitigation and protect sites before they exploit mineral resources. And they also need to get permission from local communities to do that. And so if you can get rid of the sites before you actually have to register them, you can save yourself a lot of time and money. To be honest now, I'm more worried, as I guess people are in general, as AI gets more powerful, about things that we don't even imagine the data being useful for ending up like I don't know, the model, our data somehow ending up in a model that is designed to um, uh, assimilate ethnic minorities in an oppressive country. Like, I don't know, you use archaeological sites as a proxy for the presence of indigenous people, and then the country trains a model so they can't go out and actually visit every single square inch of the Amazon forest. And so they go out and they need to, and they use these data and somehow to help them. So the guardrails are um, so far that we haven't, as much as we would like to make things open access, we have not done that yet. The sort of mantra that data want to be free and open is something that may work well with certain kinds of data, but not these kinds, and not certainly not certain kinds of personally identifiable medical data too, right? And the best solution that we have been able to come up with now is to have a kind of word of mouth registration system to get people access to the data. But once it can be downloaded, then it can be copied and it can be shared. So if there are colleagues here in the room or on Zoom or at Brown who are thinking about how to put in these guardrails, I'm all ears, because I don't. The thing that scares me the most is I don't even have a good sense of the full range of things that could go wrong. So we're just kind of trying to keep a closed shop as much as we can. Yeah, Louise.
Thank you for that. Was great. And a rather naive question. So, how do you envision or already applying the multi-scale approach?
A what approach?
A multi-scale approach. Because are you considering different scales to be different narratives, different stories different one to them? Illuminate with our research. We see a way, not methodologically, conceptually, in which those different scales that are also shaping social cultural systems. So it's not just a matter of the data, but it's a matter of the
Yeah.
how they can coexist.
Yeah. So I think we are not trying to ingest archaeological data from gray literature or like published surveys, the kinds of things that already exist out there that might help us bridge the gap between our our data and that would enable us to work across the mesoscale and the large scale, that like basically integrate our feature identifications with gazetteers of archaeological places and things like that. I think practically what has happened is that each one of these individual teams has their own scalar relations. Like they go out and they dig in the ground and they survey, and then they also have done these surveys using GeoPACHA of tens of thousands of square kilometers, and they are making sense of them in that way. One of the biggest problems here, which I almost always get as a question when I talk to archaeologists, is time. It's really difficult to date things just based on the way they look. Like, you can't look at a corral and necessarily say if it's a 15th century corral or 20th century corral, or it could be both. Um, so what we've talked about doing in order to do that, which I think is probably the missing link between the scales, is going out and doing targeted survey in a number of places, starting with LiDAR flights and then, potentially some sorts of excavations. That said, there are certain kinds of sites like Inca imperial architecture that is really chronologically distinct because the Incas wanted it to be recognized as being different. So that sort of work is better. The kinds of questions we can answer with this are either ones that do not depend as much on when something happened and are more about enduring geographic relationships between people and places. And then also questions that can rely on the visual distinctiveness of certain kinds of things like Inca forts or pucaras, hilltop forts that were built during the late intermediate period. And we just assume we know when they were built. Lots more to be said there about scale, but I noticed there's at least one more question. Amelia, you had your hand up too?
But you just
Yeah.
or you going to like the cars that you see there, whether the abandonment of like you mentioned elevation, but I don't know. Yeah, how were they just randomly abandoned or there must be some correlation?
So one thing that we have floated, but we have not yet done any work on, suggested by Scott Ortman, who is a very interesting guy, is using maybe even slightly higher resolution archaeological data to look at use decomposition models. So we can get a temporal sequence of high resolution data in particular, and we see changes in the distribution of the stones. Then we might be able to develop some way of estimating how old structures are in a particular area. Scott does this in the US Southwest at much smaller scales, though. And I can just imagine that once you expand up to the scale of the entire Andes, estimating how old a building is based on how much of it has fallen down is going to be really difficult because you've got differences in materials, you've got differences in weather, you've got differences in sort of levels of development and things like that. But it has at least been suggested to us that there might be some way to excavate the images to figure out how old certain things are. So I don't know, maybe we'll explore it and something will magically be able to happen if we use powerful enough computing. But if you have any ideas, I would love to ask you. One of the next things for the project to do, we're starting to talk to a team of linguists at Leiden about this, is there are these really expansive toponymic datasets that were extracted from maps that have place names in them, and a lot of them are in indigenous languages. And so there's some super interesting questions about whether or not herders spoke one group of languages and farmers spoke another group of languages. There are all sorts of things that are indexed in language, like the word mauchu or mauku or purun are all words that mean old place. And so one could look at the relationship between those toponyms and our archaeological data, and I think find some really interesting patterns. Doing work with, as genetic data becomes more expansive, connecting those genetic data to certain forms of archaeological sites maybe will help us reveal patterns that we hadn't seen otherwise. So I just hope that we're able to get to a place where our data are rich enough that people like you and our colleagues at Leiden who work on other kinds of data that is also historically indexed are interested in talking to us.
We're coming up on 5 o'clock, but maybe Holly will want to answer your question.